So, in this video, we are going to see about first in first scheduling, that is the CPU scheduling concept. We are going to see in this under this CPU scheduling. There are a lot of algorithms which we are make the CPU to schedule the process. So, in this video, we are going to see about first in first scheduling, then short job first scheduling, then round robin scheduling. So these three algorithms we are going to see in this video. So first of all, the CPU, what is meant by CPU scheduling? So a process, a lot of number of process has been allotted. So in this the process, how it is the CPU is how it going to schedule, that is how we are going to allocate to the CPU and complete the process. So there are a lot of ways where we can follow the procedure. So that is in this video we are going to see that the three algorithms that is used for the CPU scheduling. So first algorithm is first in first scheduling. So it is same as a queue. So you have noticed, that is you have here that queue in some of the that is in data structures, and in Python also you can use the queue. You have been seen that queue. So queue is a data structure where it is being used um, for sorry, where it is used in the data structure, where queue is first in the task has been allotted, and it will be processed in the way where first come first out. So that is first task will be enter the queue and it will be executed, that is it will be exit first. So the first member will be have the higher preference. So that is the queue. So the same way we are that is same concept we are going to use in this first in first scheduling. So the first process will come to the CPU. The first process will come to the ready queue, will be the allotted to the CPU first. Then behind them then behind the first processor process, what are they have been come to the queue, it will be allotted then and then. So that is the overview of the first in first scheduling. So now I have taken one example. So I have taken that P1, P2, P3. So in this arrival time will be 0. So I have taken as arrival time will be 0. So the user will enter the data. So enter the process. So it will take as the first, second, and third. So if user enters P2 first, then P2 will be the first process to schedule to the CPU. So in that way we are going to take. So that is arrival time will be 0. So it will be take all the process and it will be in the ready queue. So this is the giant chart. So first P1 have burst time 24. So what is mean by burst time? So burst time will be is called the CPU. Um, sorry, the So that is the CPU. That is after, that is if you allotted a process, so it will be first it will go to the CPU. So up to that the time taken to finish, that is the process will get exited from the CPU. So from the CPU will get executed the process. So the time taken to time taken by the CPU to execute the process until it get exited from the CPU. That is the burst time. So it is the time taken to execute the CPU. So that is the burst time for each processor they have been given. So we need to find the waiting time and turnaround time. So waiting time is the it. So let us consider this. P1 will be executed first. So until P1 will be executed first, the P2 and P3 will be waiting. So after P1 get exited, then only the P2 will be start executing. That is, it will go into the CPU and it will be executed. So until the P1 get finished, it will be waiting. So it will be in the wait state. So how much time it will be wait? The P2 will be wait how much time? That is the that is the waiting time we have to find. Then turnaround time is the total, the waiting time plus the burst time total up to the CPU, sorry, the process will get enter in the way, that is queue, enter in the queue, plus then it will execute the plus the burst time, that is CPU execution time. So the total of the total process, that is the waiting time plus the burst time, that is how much time it will be executed, that is the turnaround time. So that is we need to calculate. So this is the first scheduling process, and next at last we can find the average of waiting time and average of turnaround time. So this is the process in first scheduling. So now let us execute. So if the user have been given the three process, so the process will be getted from the user and it will be go in the ready queue, and the P1 will be go inside the sorry the P1 will be go inside the CPU. So uh, this is the CPU, so it will go inside the CPU and it will be executed as P1. So the P1 will start executing here. So here the waiting time of the P1 will be 0, because if the P1 will be get inside the queue and it will go inside the CPU execution. So in that the P1 the first, because the first P1 is the first to enter the queue, so it should not, because it has the highest precedence, and it will go inside the CPU, so it will not wait for the another any process is get executed in the CPU. So this is the first process is get entered, so it will be go inside. So the waiting time of P1 is 0, it will be 0. Now after that P2, after P1 get entered, and P2 and P3 will be get entered. So P2 will be entered, then P3 will be entered. So these two has to wait until the P1 should complete is turned. So the P2 will wait how much time? So the burst time is for P1 is 24. So that is 24 millisecond. It will wait for, it is going to take the time that sorry the time that P1 is going to take is 24 millisecond, that is for execution. So it should wait, the P2 should wait 24 milliseconds. So that is the P1's burst time. So that the P2 should wait 24 millisecond. Now the P3 should wait how much time? So P2 should wait until P1 should complete, then P2 should complete, then only the turn will comes to the P3. So it should wait 24 plus 3, 27. 27 millisecond it has to be waited. So that is you can take in the initial it will be 0, so it should, you can take 24. Next 24 plus uh, 3, 27. So in that way you can take. So next turnaround time is the total time. So total time is this both burst time plus waiting time. So burst time plus waiting time is 24, and here is 27, and here is 30. This is the turnaround time we are going to execute, and that average will be, it will be add this 3 and divide by 3, because the total process is here, the total number of processes 3. So that is the total number of process. So that is the first scheduling. So now let us implement this scheduling process in our programming language. So here I have been using a high level programming language called Java. So in Java I have been implemented this scheduling process. Now let us see the code. So here, first of all, we are going to get you have been seen in many programmings that scanner, this is used for getting the input from the user, and this is for printing, and next thing this is for getting the user. So you can see in the you can Google it and you can see it. Here I will explain the what are the process it is going to do. First of all, I'm getting the process, that is now how much number of process. So according to the process, I am taking, if a user give 3, so it will create 3. So I have been created an array of object, that is class. So in this class, I'm going to store burst time, wait time, turnaround time, and that is process ID. and I'm getting from the user the details. So it will execute the for loop and it will get a one by one process. So now let us calculate the waiting time, turnaround time. So here the waiting time is here in waiting time is I haven't taken as a wait call. So here wait call is initially it will be 0. So I have said the wait time initially will be 0, and n is the total number of process and p is the that is array of class. So the here it will be stored at 3, that is the processes will be stored. Now here I am taking from the array, that is sorry, I am taking from the class, that is p. First of all, I'm taking if I equal to 0 means, so if the I equal to 0 means the process is the first process. So I equal to 0 means that will be the first process. So if the first process, the wait time will be always 0. So I am taking wait call. So wait call is 0. So it will be stored in wait time. So first process wait time it will be 0, stored as 0. Else otherwise it is not a first process. So it has to wait. So it has to wait until the process 1 will get executed. So the time will be calculated. So in in that situation, the wait call equal to plus that is wait call equal to burst time. So the burst time, that previous burst time. So see here in this we have been calculate 24 how it is came, that is previous. This is the P2, P1 there is the previous process. So previous burst time we are going to take. So that is the P I minus 1. So previous burst time I am going to store in a wait call. I am going to add. So that wait call will be stored in that P2. So in this way we are going to calculate the wait time. So after come whole for loop will be executed and a certain wait time will be stored. Now turnaround time is simply you can add that burst time, that is that process burst time plus wait time. So it will be turnaround time. So at last we are going to print the process burst time, waiting time, and turnaround time, that process ID, burst time, and I'm giving the gap in this such situation by wait time and turnaround time. So at last we are going to calculate the average waiting and turnaround time. So simply you can add that each process wait time, that is initially it will be 0 and it will add each process wait time, and at last I am going to divide by n. So here total number of process, n is the total number of process is 3. So here average time divided by 3. So it will be add and it will be execute. Now let us see the output. So see here now I am giving 3. The process ID is now I am giving P1. Process burst time is 24. Process I that is next to process ID is P2, but that is 3. Next to process P3 and burst time is 3. So here process P1, P2, P3 burst time is 24, 3, 3. Waiting time is 0. Initially it will be 0. Then the previous burst time 24. Then add this both and it will be 27. Now the total of this 24, this is 27 and this is 30. So that is the and now let us the waiting average waiting time. So it will should add this wait time and by 3. So it will be 17 and turnaround time is 27. So this is the first scheduling. Now let us see the that is see here next is short come, that is short job first scheduling. So this is the short job first scheduling. In this, it is same as the first the job scheduling. Here only one change we are going to do. So initially we are getting the process and burst time, and then we are going to get a preference. So we are going to give the preference of the job. So we are going to give the that is allocation, which process you should go first, which process could so go second. So that is the preference we are going to get. So if I give in for example in this I give P1 as 3, that is preference 3, and P2 as preference 1 and P3 as preference 2. So P1 should get executed last, that is last process. It should be get executed as last process. P2 should get executed as first process. P3 should get executed as second process. So that is the preference we are going to give. So according to the preference, the I have been created in the program, that is this is the class. So according to the preference, it will be get shuffled and in ascending order. So according to the preference, it will get executed in that it will get sorted according to the preference. So in that way, it will be same as this process. So now let us, that is we can see that that is sort job first. So here, initially I am getting the process same as before in process. Yeah, first in first out. I am getting the extra is that preference. Here preference I am getting and sending to the that is class. So I am mentioned here as sort. That is sort is the I am going to sort according to the preference. So here sort. I am taking a temp, that is. Temporary array, so that is one, that the length of array is one. So I'm taking, so I'm taking that according to the preference. If that first process preference is greater than second process preference, so it will should shuffle, sorry, it should swap. So for swapping we are taking a extra variable, that is storage, and it will store in temp, and that is first process, it will store in temp. Now first process will store the second process, and now second process, in second process we are going to store that first process. So it will get shuffled. So this is the bubble sort. This is the process called bubble sort we have been performed, and after sort we are same as first in first out we are going to print, sorry, we are going to calculate. Now let us execute this. CF1, let us take same example, 3, that is process 3, process ID is 1, P1, and I'm taking burst time is 24. Now let us taking this as third last process. I'm going to give this as last process today, should be executed. Now process ID is P2, it burst time is 3. This P2 is it should be first, then P3, then process burst time is 3. Now let us give this is as second process. So first process I am given as P2. So here P2's preference, sorry, 3, P1 process ID P1, burst time is 24. I am taking as this as 3. P2 burst time is 3, and this as first process. P3 burst time is 3, and this is as second. So now let us see here, process P2 is here. P2 we have been given the preference is 1, so it is get executed first. It has first, first process should be executed. Now P3, so P3 is preference is 2, so it executed as second process. Now let last we are giving the preference is 3, so it will get executed as 3. So here P2 waiting time, it is same as the first, first in first schedule. So it will be same, it will execute the waiting time and turnaround time and the average waiting and turnaround time. So this is the shortcome. It is short job first scheduling. So next we are going to see about a round robin scheduling. So round robin scheduling is different from the first in first out and short job first scheduling. So it is different. So what is that? The certain process. So if you take some process, so this thing will be used, mostly it is used in a multi-processing operating system. So if you take a process, you can see it in many of the case, if you take a process, it should perform a certain time. So we are allotted a certain time for the process, so it should perform to, it should execute certain time. So in that time, after the time limit, it should it should exit from the CPU. That process should exit from the CPU, and next process should be allotted to the CPU. So that is the main that is the main objective of the round robin scheduling. So here the user should enter, that is should give specify a time, that is called a quantum, that is specifies by a quantum in this round robin scheduling. So quantum should be given by the specified by the user, and here we are taking as arrival time is 0. So it's then it will be the process P1, P2 and P3 will be get executed. When executed, it will goes in the queue. So in the ready queue it will be go. Now let us this test take as a chart. So it will go inside the queue. So it will go inside the queue, and it will be that is P1, first P1, then P2, then P3. So P1, P2, P3. So now we forgot this P1 in the behind the P3. Now it is now let us take, this is not a process, it is not there in this box. Let us take 1, 2 and 3. So you can take that 1, 2, 3. Now here what is the round robin is. Now we need to specify a quantum. So I have allotted here 4. So up to 4 millisecond, the see a burst time is 8 millisecond, 3 millisecond and 3 millisecond for each processor. So we are given a quantum 4 millisecond. So the process first it will go inside the P1, because we have been giving the P1 as the first. So P1 will go inside a CPU. So it is burst time is its execution time is 8 millisecond, but we are given the time is 4 milliseconds. So up to 4 it should be executed in the CPU. So after 4 it should exit from the CPU. So it is like a process incomplete state. The P1 is in process incomplete state, because because it is total the execution time it is 8, but it executing for 4 seconds. The remaining it will be the remainder is 4 second. The 4 burst time will be remaining. So here you can see that 3. So in that 4 millisecond, the process P2 and P3 can exceeded completed, that is executed completely, and it will be exit from the CPU. So that is the main thing you should understand here. So first P1, now let us calculate the waiting time. So initially the waiting time will be 0. I have been said that it will be 0. Now P1 is in that chart. Now it will take it will take 0 second. So after that is it will take 1, 2, 3 up to 4 second it will be execute. So after 4 second it will be exit, that is exited from the CPU. So now let us take, this is a CPU. So the P1 will be execute for 4 seconds. So total there is a burst time is 8. So 8 minus 4 equal to 4. So 4 will be remaining. So remainder of this so after executing the 4 the burst time should be changed as 4, because it is the remaining time is 4. So 4 will be stored, and it will be that is it will be exited from the CPU. Now next the P2 should go inside the CPU. So P2 go inside the total time. So the total time taken by the P1 is 4 second. So from 0 to 4 second it is going to take. So here you forgot about the waiting time. Here the waiting time and turnaround time in first in first out is different from round robin. Round robin there is different procedure to calculate the waiting and turnaround time. Now let us take from 0 to 4 second, that is from 4 second it is P1 is executed. So next the P2 will execute, that is burst time is 3. So under the 4 second the limit, under the limit it can execute, that is P2 and P3 can execute. So from 4 to it will take how much time. So initially the P1 take 4 time, then after P1 only we are getting P2, that is 3 seconds. So that is 4 sorry, that is 3 second, that is it will take 3 second. So 4 plus 3 is 7, so it will take 7 second. P2 should it complete at 7 second. Initially P1 it should calculate both the P1, it should wait for P1 until completing, and then P2 it will complete. So P1 will complete at 4 second and P2 so 3 seconds. So 4 plus 3 it will take 7 seconds. Same P3 it will take 3 seconds. Initially it will take 7 seconds. P2 will take 7 seconds. So 7 plus 3 is 10 seconds it will take. Now you forgot this P1. So here what we have done, the P2 and P3 get successfully completed its state, that is process. But P1 it has remaining 4 seconds. So in this case what is that, if you that initially the P1 is executing its process, that is first process. So it is executing first process. What it will do, it will execute until the 4 second, and it is the remaining it will be take as, it will store as in the burst time. So it will change from 8 to 4 because the remaining is 4 second it is remaining. So in this case if it is the case occurred, what should do, it should go at the this is a queue. So this is a queue. So this is the head of the queue. Head, this is tail. So what should do, this process should add at the tail of the queue. So sorry, this is that tail of the queue. Initially it has only three process. So initially it has three process. So what else, after P1 is completed, that is after P1 get executed for 4 seconds, it should it has remaining 4 seconds. So it will add at the tail. See, tail of the queue, the one box will be created and it will be add P1, and it should be removed here. That head of the queue should be removed, then only you can go for P2. So the P2, now P2's turn will come, then it will take only 3 seconds. So it will execute until the between the limit. So it will execute and it will be removed from the queue. So same P2 P3 will be execute and removed from the queue. Say next the queue will be have only one, that box, that P1. So it here it has the remaining 4 burst times. So the limit is 4, so it can execute the 4 that is within the limit, because it is equal to, so it can take equal, it can take 4 seconds completely. So it after it executing, the total time here initially the P3 will have 10. So it takes 4 seconds, that is remaining burst time is 4. So 10 plus 4 is equal to 14. So the total P1 time will take as 14. So this is the total time. So this is the way we are going to calculate. If you have greater than 8, so if you have 12, so if for example if it has 12, another one box will be created, and here will be remaining 4, because here 4 plus 4 is 8, and 4 plus 4 8 plus 4 is 12. So another one box. So if you take 24, it will be have more than 3 box here for P1. So it is the, like this we are going to calculate. Now the total time is here is 14. So for P1 it has take 14. Now we can calculate the turnaround time, that is turnaround time. So before calculating waiting time, we need to calculate turnaround time, because in turnaround time only we can calculate the waiting time. So here arrival time is 0. In this case the arrival time is 0. If arrival time is 4 second, then it will be this chart will be varies. So we have taken that arrival time is 0 here. Our question is arrival time is 0. So now turnaround time equal to total time of the process. So if you take P1 process, so P1 process is total time it takes 14 milliseconds. So 14 minus arrival time is 0. So it is 14. So you then total time of P2. So P2 it takes, it is 0 to 4. So P2 it takes 7 seconds. So 7. Then P3 it take 10. So that is the turnaround time. That is the, sorry, this is the total turnaround time. Turnaround time. Now from turnaround time we can calculate the waiting time. So waiting time, you have see that formula is turnaround time minus burst time. So turnaround time is 14. 14 minus 8. initial the burst time, the initial you have given the this is the remaining time, so you need to store this burst time in separate variables. So in program I will show you how I have stored. So this is the initially you are given that burst time is 8, so 14 minus 8 is that is 6. Next 7 minus 3 is 4, and 10 minus 3 is 7. So this is the waiting time. Now next we can calculate that average of the turnaround and waiting time. Now let us see in code. See here, first I will take a hash receive, that is taken the number of process. So after that process I'm taking an array, so sorry, a class. For a class I am creating a object. So in each object I'm getting id, burst time, and sorry, this is the wrong short job. So here I am getting the number of process, then job. So jobs is the this is the array I'm going to store. This is I will say you later, and the time will be store getting, and I'm taking the class and adding this burst time and process id, and I'm sending this to that, and I'm created a queue. So see here I have been created a queue here. See here queue. So this is the inbuilt queue I have been taken from the Java. So that is the inbuilt queue. So that is when I'm getting the process from the user, at that time I'm adding to the queue. So it will be p1, p2, p3. Now it will be p1, p2, p3. I'm taking the round robin. I'm performing round robin method. So here I am what I have been done. Initially I'm taking the queue. Initially the queue will be now three process. If I have been given, the three process will be stored in the queue. So if it is empty or not. So the last, that is the termination condition, is here after p1 get after p1 get executed, it will be removed if the remainder is 0. So it will be removed and queue will be empty. So in that case only it will the program will complete. So in that case I am taking whether queue is empty. Whether queue is empty, no, it is not empty, so it will be false. So that is negation of false is true, so it will get inside the while loop. So if queue is empty, then true, then it will goes false, so it will get executed. So in this way you can process. So now I'm taking a process, I'm taking a that is class, that is I'm taking a object. So that is peak. I'm taking first the queues first peak is for fetching the first that is first element in the queue. So I'm taking the first element in the queue, that is first object in the queue, and I'm taking the process temp burst. I'm taking the that is temp burst is the temporarily I'm storing the burst. So temporarily storing burst equal to process burst time minus quantum. So the burst time minus quantum is it should take. So if you take see here I'm taking here 8, so quantum is 4, so I'm taking burst time is 8, so the remainder is 4. How it is, we are getting minus, so 8 minus 4, that is burst time 8, quantum is 4. 8 minus 4 is it will store in the temp burst. So here the remainder is storing, and I'm taking the temp burst is greater than, sorry, less than or equal to 0. So in this case, so see here I'm taking 3. So 3 minus 4, it is in minus, so minus 1. So in the minus 1 is the state it get executed completely. So that is the state here. So that is the case I have been given less than or equal to 0. So in this case the wait that is total time. Total time is process dot burst time. So here the burst time only we are taking that 0 plus 3. So 3 that we are going to calculate. So here I am taking 4 plus 3. So that is the time we have been calculated. So the burst time only we are taking the time for this. Here we are taking the quantum. So here 4. It will take 4. So in that case we are taking burst time and adding to the wait call, and process total time equal to, and process total time equal to wait call. So next the job of I equal to process. So I am adding in a separate this jobs uh, because it is already in a queue. For displaying this we are, I am creating an array object of array, sorry, class of array. In that class of array I am taking this process I'm storing in job of I. So I'm taking I plus plus, that is I plus plus. This is the this is the execute, that is the process will be executed completely state. So in else part it will be the remainder part. So remainder part it will be take the burst time quantum, it will be add, and the process total time will be add, and it will be add to the tail of the process. So it q dot add it, so it will add at the tail of the process and it will be removed. So it that removed state it will be add at the tail of the process. So in this case the that is queue is will not be empty. So in this case only the queue will be empty. So in before we are removing, it is adding to the job first. So in this case we have been calculated, and last time calculating the turnaround time equal to total time. So total time we are taking as turnaround time, waiting time equal to turnaround time minus the dummy. So dummy is the variable I am storing here. In that initially I am class I am storing dummy equal to burst time. So burst time, that is we have I've been said that initial burst time should store in a separate variable, so I am storing a dummy. So here I am, at last I am printing, calculating the average weight and turn, and I am printing, that is in job id dummy value, waiting time, turnaround time, and after that I am calculating the average. Now let us execute this code. So total number of processes 3, quant time 4, process ID P1, burst time is I am giving 8, process ID is now next process ID is P2, burst time is 3, next is P3, burst time is 3. So see here, it take P2, so P2, so initially we are taking as burst time P2, so burst time is 3 and 3 and 8. So it will take 4, 7 and 6, and turn around is 10, 14. Now let us execute another valid process. So I am taking as 3, quant 4, and the process ID is P1 I am taking as 24, and P2 is 3, P3 is 3. Then process time, you have seen that P2 is 3. So initially the P2, the P see here the P2 and P3, so it has the burst time 3 3. So this will be initially it will be executed first, and it will be stored as job or in the job array. At last only P1 will be execute is the process, and it will be stored. So for that only the process I would then sort it well, so and simply have been printed. So in this way it will be created, and if you see the turnaround time will be calculated. So the waiting time is 4, 7 and 6. The turnaround time is then the last, it take 30 second. The total time is 30. So 30 second, it millisecond it will take, and it will be calculated from waiting time. The average waiting time and turnaround time will be execute, calculated. So this is the CPU scheduling algorithm, that is first scheduling, for short job first scheduling, and round robin scheduling algorithms, and implemented in using this Java. So that's it from me. Thank you.